One of the most important theorems in calculus is the mean value theorem. Let's start. First of all, write it down. The mean value theorem states that if f is continuous on a closed interval, a to b, and differentiable on the open interval, then there exists a number, c, in a b such that the derivative of the function evaluated at c is equal to f of b minus f of a divided by b minus a. Now, let's kind of pick this apart. Basically, what we're saying is there's going to be a point, and we don't necessarily know what that point is, but we're going to call it c, so that the slope of the line at c is equal to fb minus fa divided by b minus a, or the slope of the secant line connecting those 2 points. Let's see. Let's try to, let me just show you why this works. Let's say this is my function, and let me write an equation for the secant line. Let me go to my pen here. Let me go to my pen in a reasonable color. Purple's good. And we're going to find the equation of the line between these 2 points. Now, you know, I'm going to call my curve y. So y minus f at a has to equal the slope of this line, and the slope of this line is rise over run. So it's fb minus fa divided by b minus a, and that's times x minus a. Let me solve this for y. So y is equal to f evaluated at b minus f evaluated at a divided by b minus a times x minus a plus f evaluated at a. Now, let's define another function, g of x. And let me let g be the difference between f of x and y. So it's f evaluated at x minus y. So let me write out what g of x is. G of x then is, quite nicely, f evaluated at x minus, now I'm going to put this in brackets here, f at b minus f at a divided by b minus a times x minus a, and then it's going to be minus f evaluated at a. Now, let's evaluate g at a. What is g? Oh, let's not do yellow. Let's do red. Let me erase this real quick. These proofs always take so much time, don't they? But they're good for you to see. G evaluated at A is going to be F evaluated at A minus, can I just put this in brackets here? A minus A minus F evaluated at A. Okay, do you see what's going to happen? These two are going to cancel, and this is 0. So G at A is 0. Now I'm going to evaluate G at B. All right, so this is F evaluated at B minus, and I'm going to go and write it out this time because I need it, F at B minus F at A divided by B minus A times B minus A minus F at A. Let me rewrite this now. See, this is going to cancel. This term right here is going to cancel with this term down here. So it's going to be F at B minus F at B. Oh my goodness, I'm seeing something here. Plus F at A minus F at A. Goodness gracious, this is also 0. So I have G of A equal to G of B, and it's equal to 0. All right, so I know F is continuous, And since f is continuous, g is also continuous, and they're also both differentiable. So I can apply Rolle's theorem to g so that I know, let me switch pen colors here, that 0 has got to equal the derivative at some point in there. So what is the derivative of g with respect to x? Well, that is going to be f prime at c minus, and I'm just taking the derivative here, with respect to x and evaluating it at c, that's going to be minus f evaluated at b minus f at a divided by b minus a. The rest of those are constants, so they go away. Now this is 0. Let me solve this for f prime at c. This is f at b minus f at a divided by b minus a. Now, you're not going to have to prove it more than once on a test or quiz, but you are going to have to use it. Why would we use it? Well, suppose we want to find a tangent line. Suppose I'm given this function, and I want to find all the values such that this is true. Well, I know the slope of the secant line between 1 and 4, because I'm on this open interval, is, let's see, f of 4 minus f of 1 divided by 4 minus 1 is equal to, well, f of 4 is 4. F of 1 is, 1, that's interesting, divided by 4 minus 1, and that's just 1. Now, f satisfies the conditions of the mean value theorem because we're continuous and differentiable through the entire open region. So there exists at least one c such that f prime at c is equal to 1. So solving the differential equation, f prime of x equals to 1, I get f prime is 4 over x squared. That all cancels. This equals 1 when? Well, that's when x squared is 4, or x is plus or minus 2. Now, your turn. Turn off the tape. Do this problem. When you're done, turn the tape back on because we have another really cool problem. All right. Now, police officers don't do this, but it would be kind of cool if they did. You're driving along the road and you see a police officer and you are doing exactly 55 miles an hour. You're good. So at t equals 0, you're doing 55 miles per hour. Now, 4 minutes later, so this is going to be t equals 4 minutes. All right, you pass a second patrol car and you're doing 50 miles per hour. No chance of you getting a ticket, right? Well, let's see. If your police officers were calculus savvy, you might be in trouble. All right, let's look at this from a calculus perspective. First of all, let's convert our time. I just lost my pen thing. Where'd it go? Where'd it go? Goes, okay. Time is equal to, let's see, you know what, let me do this. This is 5 miles. Taught physics for too long. I have to have all my diagrams. And my time is 4 minutes. All right. Now, I have to convert this all to hours. So I have 4 minutes is 60 minutes, so this is 1/15 of an hour. You have to have all your units the same. Let's let S of t equal your distance function traveled by u. And I know s at 0 is 0 because you haven't moved anywhere. This is just when you first cross the plane. And then s at 1 over 15 is how far he traveled, and that's, of course, 5 miles. Okay, so the average velocity, and you're going to use a bar for that, is s at 1/15 minus s at 0 divided by 1/15 minus 0. So this becomes, just do a little bit of algebra, 75 miles per hour. So we're going to assume your position function is continuous and differentiable. You can apply the mean value theorem. By the mean value theorem, you're going to get a ticket. U for speeding. Now, see if you can do one. When you're done, turn off the video, finish your homework. Have a great evening.